Geek Therapy Radio.
Welcome to the Geek Therapy Radio podcast. You've got your mental curator, Johnny Hamburger, and we've got some things to talk about here. Mainly, the meat and potatoes is going to be, well, Apple news with the M1 processor and the MacBook Air and the other devices. Specifically, we're going to focus on the M1 SoC. But before we do, I want to mention one quick thing. Friend of the show, Asaf, emailed me earlier today, and it was in reference to the previous episode where I posed the question, has technology kind of lost its magic? And in that episode, I was mainly speaking about video games, more or less, and kind of television and things like that, consumer type of what we consume with our eyes and ears and what we play with, video games and whatnot. Asaf pointed out a very good point, and it's something that I didn't remember during that show, but it's incredibly valid. Technology is still magic in other avenues in other areas beyond video games and kind of, movies and Blu-rays and VHS and all that kind of stuff. For instance, 3D printing. That is still a very magical technology to get excited about. That's really cool. You can literally download an object off of the internet and then have it exist in your real life. That's really, really neat. Let's say you're building a model airplane and you need a very specific, gear for the engine or for the landing gear or something like that. You need a cog, you need a gear. You can literally download it on the internet and print it out and have that physical thing. You don't need to go to the store. You don't need to order from anybody. You can actually download real objects that then exist in your real world. That's really cool. That's magic. That there is still a sense of awe and wonder there. And we've only just begun with 3D printing technology. The other thing that was very interesting and that I thought was magic, that the first time I what do you call it? I use this device. Are drones. The first time I flew, the first major drone that I bought was the DJI Phantom 3, I want to say, the Phantom 3. And the first time I flew that, I literally had this magical sense that I was flying, that I had this freedom to explore my world in 360 degrees in 3D. I could fly above buildings in real time. It felt like I was flying. There was real magic. There was real goosebumps. There was real just awe and wonder at using that technology for the first time. I would say that VR is also... I took that back, because in the show previously I said that I wasn't entirely blown away by VR in the same way that I was blown away by NES to SNES, but VR was still very cool. As far as the gaming is concerned, it was still kind of the coolest leap that I felt since going from the NES to Super NES, going from PlayStation 3, 4, now 5 and stuff, and then jumping into VR. It's a really cool jump to make, but it was still kind of an expected thing. But it was really cool. But yeah, flying a drone, 3D printing, those are all very magical aspects of technology that I still feel that childlike wonder for. So, Asaf, thank you for emailing me. Asaf also found some computers in the street, and I forwarded this email to Colin and Clint and David Murray. He found a portable TRS-80 and an IBM 5150 just lying in the street. Yeah, they look like they're in rough shape, but I'll keep y'all informed if he keeps me informed as to that restoration process. I wish him all the luck in the world, and I'm super duper freaking jealous. He would kill me if I didn't mention this, and I'm glad I remembered that. Does anybody have a DAT recorder or a DAT player, digital audio tape? So the Super 8 tapes, 8mm tapes, they record digitally. You can record up to 8 tracks of audio. It's kind of like an ADAT, an Alesis ADAT, but it's using the high 8 cameras. DTRS is the technology. So does anyone have like a Tascam DA 88 or any other sort of DTRS player, he has a tape, and he wants to see what's on it. He's very curious about that. So I'm just curious if anyone in my audience still has an 8-track Hi-8 DAT player recorder that we can put this tape in and maybe see what's on it. I used to have a DA88. I gave it away. At the time, I gave it away maybe 5 or 6, 7 years ago. I was like, this technology, no one's going to care about this. And that's the funny thing about technologies. We'll look at something, no one's going to care about this. VCRs, no one's going to care about this. And then like 5, 10 years later, we're geeking out about it again. And it's nostalgic. And now they're rare because we all threw them away or gave them away. And now they're expensive on eBay again. So anyways, let's move on there. You know how to contact me, by the way. If you have a DA88 or a DTRS player, any sort of DAT machine, you can let me know, geektherapyradio.com, and let me know, and then I'll let Asaf know, and I'll hook you guys up. On to the meat and potatoes. I don't know really where to start with this. With the M1, Apple M1, we finally had the One More Thing announcement today, and there is a lot to unpack there. And I'm not going to unpack every single little nitty-gritty detail about it, but I'm going to go over some important bullet points because I have some of my own kind of personal thoughts on this, and I would like to know what you think as well. Again, geektherapyradio.com, and let's talk about it. So, the M1, let's just start here with the graphics. They made big claims about the graphics in the release of the M1 processor that new Macs are going to run off of. So the MacBook Air, the Mac Mini, and what was the other thing? Oh, the MacBook Pro. They claim for the graphics, let's just scroll down here, that the graphics are, where is it? I'm so sorry. That it has the world's fastest integrated graphics. That's the most concise way to put it. The world's fastest integrated graphics. So what does that mean? So they give some numbers here. 25,000 threads simultaneously. The GPU can handle extremely demanding tasks. So 4K video streams, multiple 4K videos, render video streams, 3D complex scenes, and here's the little tidbit of information here, the actual kind of data point. 2.6 teraflops of throughput. The M1 has the world's fastest integrated graphics in a personal computer. 2.6 teraflops. Let's go off of that data point for a moment. For reference, the RTX 3080 has 29.7 teraflops. The M1 system on chip in new Apple products is 2.6 teraflops. But that's not really a great comparison, obviously, because the RTX 3080 is not integrated graphics. It is very much so discrete graphics. So 2.6 teraflops versus 29.7 teraflops isn't a fair comparison. But I wanted to kind of give that comparison in general, though, so that we know where kind of a flagship GPU rests. The RTX 3080 is very much a flagship GPU as of recording right now, and it's at 29.7 teraflops. The more apt comparison would be for the integrated graphics on 11th gen Intel chips. So I still don't know how to pronounce this. Iris Z? Is that how you pronounce it? Iris Xe. So I know how to pronounce Iris. It's no longer like Iris Pro or HD 5600, whatever. It's now Iris G graphics. I'm going to pronounce it G because I think that's right. So integrated, the iGPU on 11th gen Intel chip, so the i7 11th gen Intel chip, which is a 10 nanometer process, Intel Iris G iGPU is 2.1 teraflops. So Iris G integrated graphics is 2.1 teraflops, and the M1 and Apple is 2.6 teraflops. So yes, on paper, just with grunt, the M1 has better integrated graphics than even 11th gen Intel chips. Intel has dove into their own discrete GPU, the Iris Z, Iris Z Pro or whatever it is. It's at 2.46 teraflops. It's kind of comparable to NVIDIA's base model MX250, MX450 graphics, discrete graphics. But still, even that is at 2.46 teraflops versus the M1's 2.6 teraflops. So the M1 has better integrated graphics. It even has better baseline dedicated graphics as the dedicated G graphics that Intel is about to introduce into the ecosystem. But here's my thoughts on that. So the Iris G iGPU at 2.1 teraflops versus the M1's 2.6 teraflops. The Intel G iGPU is available on products now as of I think like September or something like that. The Dell XPS 13, for example. So yeah, you put up a MacBook Pro with the M1 2.6 teraflops graphics versus the XPS 13 at 2.1 teraflops. Yep. Mac has the upper hand there as far as integrated graphics. Now, here's the rub with that, though. The M1's integrated graphics are great for native Apple software like iMovie. When they talk about multiple 4K streams, that's what they're talking about. Native Apple software like iMovie. But the jury is still out on third-party software like Premiere until if and when it is optimized for the M1 ARM and or we see benchmarks in the wild. And believe me, we will. You're going to see Jonathan Morrison and Austin Evans and Linus Tech Tips doing all sorts of benchmarks running Premiere and Final Cut and running Pro Tools and things like that on the new M1 chip in Apple hardware. But we have to wait for that. Is it still going to be that kind of amazing performance on third-party software? And I can't argue to that right now because we just don't know. We haven't seen the benchmarks. At least I haven't seen. Have you seen somewhere on the web where you have benchmarks for Premiere running on the M1 chip? So like rendering times in Adobe Premiere versus iMovie or Final Cut, whatever. I haven't seen that anywhere as of recording. As of right now, we can just assume that third-party software, I'm getting a little bit ahead of myself here, we can assume the third-party software, again, non-native Apple software, third-party software running through Rosetta 2 and other emulation programs baked into the newest version of iOS, we can assume that since it's emulated, it's going to run a little bit slower. So all of these kind of performance improvements that Apple is touting, that's naturally only going to be towards its native software that's already coded for the M1 processor. We may not see the benefits of this M1 chip on third-party software for quite some time. I hope it's not that long. I mean, I hope Premiere is optimized for the M1 in a few months. I hope Pro Tools Avid gets on the horse and optimizes for M1 in a few months. And you know they're going to be working on it, or we can hope that they're going to be working on it. So these graphics claims, for instance, again, that's for native Apple applications like iMovie. Jury is still out on third-party apps like Adobe Premiere. They also mentioned that it's great for gaming. And that anybody who hears Apple touting great gaming, they scratch their heads. Who is getting an Apple? Who's getting a Mac for gaming? Who are they mentioning here? You know, maybe iOS apps that are coming over to Mac OS. Like, what? Are you going to be able to play Candy Crush better or Asphalt 8 better on this M1 chip and these like mobile games? They're not talking about AAA titles here. You can't imagine that they are. But that said, you know what? Who knows? Maybe we'll find more Steam games optimized for the M1 chip in Mac hardware. Maybe. Mac gaming has never really been a thing. I don't know why it would be a thing now. It has just to do with market share. There's way more gaming PCs than there are, Macs out in the world that are used for that purpose. But we'll see. As far as gaming, it's funny to me that Apple makes these claims that this M1 chip is going to be amazing for gaming, but it's like, what games? What are you talking about? Is the next Assassin's Creed coming out specifically for Mac? Maybe. Who knows? So, gaming performance, okay. I mean, we'll see. I'm sure it's great for mobile games running on a MacBook Air, for instance. Let's talk about the system on chip for a moment, the SoC. You have 8 processing cores, so the main CPU cores, 8 cores. There's 4 big and 4 small. So the 4 big cores are single-threaded, and they are for just running the big grunt, like not video encoding, but it'll help with rendering. It'll help with kind of the more CPU-intensive tasks. And then there's 4 small cores that run the less demanding tasks. So you're typing a paper or you're opening up an MP3 or something like that. That's going to run on the small and the background tasks and like updated weather and things like that. That's going to run on the 4 smaller, more efficient cores. So 8 cores, 4 big, 4 small. That's nothing new with ARM processors. So since this is a system on chip, the core count isn't so critical since all of the auxiliary hardware is within this system on a chip itself, within the SoC itself. So it's almost instantaneous throughput. For instance, codecs normally, several inches away on the GPU are now on the same exact chip with the CPU and instantly accessible. Also, the RAM is contained within the SoC itself, and it is shared by every component within the SoC, like the GPU, the neural engine, etc. This also, unfortunately, means that the RAM is non-upgradable. But to me, that's it doesn't matter, because when is the last time RAM has been upgradable in a Mac laptop? Especially, it's been soldered on for years. You haven't been able to easily upgrade the RAM modules on a Mac notebook for years and years. So when you order a MacBook Air, MacBook Pro, Mac Mini, whatever, you're going to have to spec 16, 32, 64 gigs of RAM, whatever you want. You're going to have to be sure that that's going to be enough for you down the road, because you can't go back and upgrade the RAM. On the flip side of that, like I just mentioned, since everything is already on the chip, since the RAM is already on the chip and it's all shared by everything in the system, the GPU, neural engine, CPU, all of that stuff, that means the I/O throughput between the CPU and auxiliary hardware like the RAM and the GPU were huge bottlenecks in traditional systems like x86 systems, Intel systems, when that's not all on the same chip. So you have your GPU over here, you have your audio hardware over here, you have whatever little system chips are running different parts of the system all spread out across the board. It's kind of like having the entire system on a chip, having the RAM right there, having the GPU right there, having neural engine right there, having your cores right there. It's kind of like having everything you need at your desk instead of spread out across town. So it's way more efficient, and it was, even in the best systems, the I/O throughput between all these different components having to communicate with the RAM, communicate with the processor, communicate with PCI Express, all that stuff, it's all within the same chip on the M1. So you have just light speed, instant. The speed of light, the speed of electricity is traveling a few millimeters, a few nanometers, as opposed to traveling several inches across a board. And I know that sounds silly, several inches as opposed to a nanometer when you're talking to light speed, but it does add up. It does add up, and it makes the system all the more responsive. My only point there is that 8 cores, 4 big, 4 small, the core count is less kind of critical. I say less critical when everything is contained on the same chip. When everything is within arm reach, those 8 cores, the 4 big, 4 small, can operate at peak efficiency. And speaking of efficiency, this also means unprecedented efficiency. The system on chip can process more instructions and perform more functions per watt than any other chip in the world. So in a nutshell, it can do with just 10 watts what it takes Intel to do with 40 watts. According to Apple, it can perform the same functions using 25% of the power that it takes competitors' chips to use. So 25% of the power, that would mean basically, like I just said, it can do with 10 watts what Intel and AMD can do with 40 watts. That's kind of an arbitrary number. That's going to be a rough number. It's just based on the 25% power efficiency that Apple claims. It's not set in stone that it's definitely can do at 10 watts what others can only do at 40 watts, but it's a decent comparison. So on to x86 and x64 compatibility. So basically third-party programs. Let's touch on that again. Rosetta Stone 2 essentially allows for x86 and x64 emulation, while the developers of those software titles recode for ARM. They recode for the M1 processor. So like I said before, it could be that all these performance gains Apple touts is only for native software like iMovie, and most third-party software titles like Premiere and Pro Tools we won't see how it performs on the M1 for real until it's coded for the M1. Right now, it's just going to be emulated and recompiled on the fly kind of for ARM processing, and that's not the most efficient way to do it. So in the past, Rosetta has been a temporary stopgap. So when Apple transitioned from PowerPC chips to Intel chips, they removed Rosetta Stone with subsequent upgrades to, I think, like OS X Tiger or something like that. It went away after a while. Once all the third-party developers were developing their software for Intel chips, they didn't need Rosetta anymore. So Rosetta in the past has been a temporary stopgap. However, Apple has been proactively issuing developer transition kits to help speed up the transition to native M1 ARM support. So Apple knows this and has been actively sending out these dev kits to the third-party developers like Avid and like Premiere to say, hey, right now it's going to be emulated on our new M1 chip, but here's the tools you need to recode for our M1 processor to run natively, and that's great. That's why I say it's only a matter of time before we see this third-party software running perfectly, beautifully, natively on ARM M1 processor and Apple hardware. So this is what actually gets me really excited. Popular software like Pro Tools, and I'm an audio guy, I use Pro Tools all the time. Popular software like Pro Tools could be coded for ARM processors, specifically the M1, sooner than later. And that means that, relatively speaking, it's only if, I do mean relative, I'm oversimplifying here, it's only a few lines of code away from running on other ARM platforms like the Snapdragon or Exynos chips in our Android phones and tablets. So, and again, I know I'm getting ahead of myself, and there are undoubtedly people who disagree with this, but how cool would this be? If Avid offers Pro Tools in the Apple Store and have already done most of the heavy lifting recoding it for ARM anyways, why not go for the extra sales potential of offering it on the Google Play Store? Full-blown desktop software running on my Samsung in DeX mode? Freaking sign me up. The idea that I could like Streamcast or just cast the screen of my phone to a TV wirelessly, or even plug it in with USB Type-C or Type-C to HDMI or whatever, and just have a foldable Bluetooth keyboard and a travel mouse, and be able to plug in my phone to any TV in the world basically, and have my full-blown Pro Tools and be able to do my podcasts easily and work on audio production and video edit and all sorts of things just with my phone. I mean, that's where it's supposed to be all headed anyways. That's where it's all headed anyways, really, at the end of the day here, as we transition to ARM. And for some reason, I respect it, but there are people who disagree with that. Oh, there already are software that you can already make podcasts on your phone with Apple apps and stuff like that. And I know, I've done it. I've done an entire radio show using Audio, what is it? Audio Evolution? Let me look it up on my Samsung right now. Yeah, Audio Evolution is arguably the best DAW, digital audio workstation, on Android. And it's great. It is great for what it is. But if you can, I believe most people can kind of sympathize with this and relate to this. You get comfortable with software, and it's a pain in the freaking butt to, let's say, get very familiar with Pro Tools and then go over and use Reaper or use Adobe Audition or something like that. Yes, they all do the same thing, but everything's in a different place. There's different ways to do everything. You don't know all the keyboard shortcuts. It can take you 10 times as long to do the same thing using software you're not familiar with, versus, hey, if Pro Tools was just on my phone, full-fledged Pro Tools was just on my phone, and I could cast the image to a TV and work on it in full screen, and even in a pinch work on it on the plane in the small screen, or have it on my tablet or whatever, and I wouldn't need to bring my laptop around for half the things I need to do. That would be awesome. And why not? It's just an extra option. And if they're already coding for ARM anyways, why not? And I know this is wishful thinking, and I'm getting ahead of myself a little bit, but isn't that where it's all going? So like I said, I know it's easier said than done, and it's a bit more complicated than just a few lines of code between an Apple M1 and a Snapdragon processor. So to add to other hurdles, programs like Pro Tools, for instance, use plugins. And basically plugins are third-party software programs running within another third-party software program, and would also require recoding for ARM. So your VSTs and DXI and what are the RTAS that Pro Tools uses would need to be coded for ARM. Does Pro Tools still use RTAS? I forget. Anyways, all those little plugins are basically third-party software within third-party software. So Universal Audio, for instance, makes a lot of plugins for Pro Tools and for Cakewalk Sonar, for everything. Universal Audio, UA, would have no choice but to keep up with Pro Tools, which means that UA would have no choice but to recode their plugins to work on M1 or ARM-based processors. It's a hurdle, and we'll see how fast these third-party developers make the transition to M1 and to ARM. So at the very least, the next few years will be fascinating. It's a really cool... This is all kind of a roundabout way to bring it back to the last episode. Is technology still magical? I would argue right now that this transition to ARM in earnest, kickstarted by Apple in the year 2020, is a very exciting, magical time for personal computing. Very, very exciting. It's a really cool time to keep abreast of consumer technology. This transition to ARM will be amazing, and it is amazing, and it is magical, and it's a whole different it's a whole different architecture, it's a whole different way of processing instruction. It's really cool. And for a fellow geek, or even if you're not so much of a geek about technology, it's still a fascinating thing to keep in touch with. Whether or not you're interested in it, you're going to be using it in the next few years. That's kind of the cool transition of technology, is it doesn't matter. You're going to be using it. It's kind of like when I was in high school and being made fun of for carrying around a Palm Pilot. I was like, look, in the next 10 years, this is going to be your phone, and you're going to be a dork for not having one. Mark my words. It's kind of a similar transition. Not that you're going to be a dork for using an Intel processor versus an ARM processor or whatever, but I'm just saying it's a technology that's going to advance, and you're going to use it whether or not you are actively invested in keeping up with its advancement or not. If you're a geek about it or not, you're going to be using this technology in the next 2 to 10 years as we transition to ARM. On Twitter, I mentioned, what did I mention on Twitter? Something about ARM processors. Let me go back to my account, and Colin tweeted at me also something that I agree with. Where is it? So what I mentioned on Twitter was, quote, game developers have been optimizing games for Intel chipsets for the past 15 years because Intel was king. Mark my words, with AMD surpassing Intel performance today, I was talking about AMD here, with AMD surpassing Intel performance today, developers will begin optimizing their games for AMD. Just another blow to Intel. And Colin responded with, the sun is setting on x86. Smart devs will start thinking about ARM soon, and those writing mobile or Switch games, Nintendo Switch games, already have the leg up. And that's very true. The sun is setting, at least in the consumer space, on x86, x64. That's true. So not only my sentiment that, well, as far as gaming PCs are concerned, AMD is now the king, so developers will start optimizing for AMD. Because remember when you loaded up games, it would say like optimize for Intel Core 2 Quad, optimize for NVIDIA, stuff like that. Now it's going to say optimize for AMD Threadripper, or not Threadripper, it's going to say optimize for Ryzen, something like that. You're going to see more AAA titles have those splash screens. Instead of optimized for Intel Core series or best played with Intel Core i7, it's going to say best played with Ryzen 7, Ryzen 9, whatever. Because now AMD, more people are going to be buying AMD for their gaming rigs because they're not going to buy the less powerful processor for their gaming rigs. PC gamers want the most powerful bang for the buck, and right now that's AMD. So the developers are going to start coding more and more for AMD. To Colin's point that Actually, in the interim, yeah, they're going to code for AMD, but smart developers like those who have been developing games for the Switch and whatnot and mobile games, they've already been developing on ARM, and that's where the future is going anyway, so they actually have the leg up. I fully agree. We're transitioning to ARM over the next few years. And it's going to be relatively short. You know what? I'm going to end the podcast right here to keep it under 30 minutes so I don't have to do an ad. Thank you for listening to Geek Therapy Radio. You are worthy of love. You are worthy of your own self-respect. You are worthy of giving and receiving love. We're all geeks about something. Here's the bombshell. All of this audio came from VHS tape. Wow.